6 inches down on the exterior side.
No, because then you would see it.
No, I'm saying just like 6, like coming down the length of 4 inches.
We're going deep in the weeds right now, so it's not 6. It's 6. So if this is 1.5 inches. So what is deep in the weeds? Let's talk about deep in the weeds. Deep in the weeds is going to be an educational seminar or some kind of little lesson where we're actually going to draw stuff full scale and really try to understand what we're looking at and what's good, what's right, what's wrong, how's it going to work, is it going to work, is it not going to work? And let's talk about today's subject. So today's subject, James, could you pull up the photograph? We are on a bulkhead roof. It's quite a large bulkhead roof. Bless you. Bless you. This is real and unscripted, by the way. Bless you. What we're looking at is we're looking at a penthouse roof. And the penthouse roof, for the conversation of this lesson, is we're going to say it's 5,000 square feet. If the penthouse roof was like 200 square feet, nobody would care. It's a tiny little thing, right? But 5,000 square feet is enough that it's going to be big enough that it's going to, whatever decision we make will have a financial impact. So the question is, this roof right now has no insulation. It's an old roof. It's an old modified roof, no insulation. We took the probes. There was 1/2 inch of coverboard, and that was it. The pitch is created with the slab. It's got cinder fill on it. And we have an old copper cap flashing right here. We're looking at a scupper detail. So this is the low point of the roof, right? The thing pitches down and goes out the scupper. So right here we have roughly, scupper is roughly 4x4, a little bit more on top. For conversation, we're calling this 8 inches. Now good roofing practice is to have 8 inches of base flashing on the side of the roof. What is the base flashing? That's the bathtub, the sides of the bathtub. Okay. Industry practice is 8 inches, and we have that roughly. And then we have 1, 2, 3, 4, 5 courses above. We see we have some conduits running on here for power to go to an exhaust fan. And then we also see at some point they must have had some kind of leak and they painted the wall with mastic. So the mastic is going to come into play as part of our decision. So what we're trying to figure out today is, how do we bring this up to current energy code? How do we insulate? And we have two choices in the modern world of insulation. To sidestep, we're going to keep this as an exposed roof membrane. It's a conventional roof membrane, which means the insulation will go below, and we have you would walk on it. You would walk on the membrane. And we have two choices. Choice number one is we're going to go back with 6.5 inches of polyisocyanurate. That's our normal roofing insulation in a conventional roof. And choice number two is, do we use the modern vacuum panel? What's the modern vacuum panel? I have no idea. I'll tell you what it is. It's a new technology. There's a company that came out with it. And what it is they'll take, it's like believe it or not, it's like a space age refrigerator technology where they take a mylar and they wrap it around the insulation and they vacuum out the air. And by doing that, you get a very high R value in a very thin application. Why do we care? Well, because we need to know if we only have, now we're going to go deep in the weeds. If we have 8 inches here and we have 6.5 inches of new styrofoam that we need to add, polyiso, not styrofoam, polyiso, that means we're going to have no sides of the bathtub. None. And what it would mean is we need to take out this in-wall cap flashing and raise it up. Now, there's a cost to doing that, and we're going to get into cost in a minute. So first, we have to decide if we add 6.5 inches here, plus 8 inches, where is that going to get us? Well, let's go to the videotape over here. We have a couple little mock-ups drawn already. So in one scenario, we're going to go vacuum insulated panel. We're going to call that VIP. And over here, we're going to call, this is your traditional 6.5 inch R33 polyiso. So we have two scenarios, and we're going to try to figure out which is more cost effective, which is easier, and which is better. Yes, Bill?
Do we have to worry about the height of the parapet? That doesn't sound like it.
For the purposes of this discussion in terms of railings and like falling off the buildings, we're not going to get into that here, only because we're really just trying to determine whether or not we want to. I'm gonna ghost this in. So right now, down here is our existing. That's our existing cap flashing. We have 3 courses. So we go here, back here, 3 courses below the cap flashing. That's 8 inches. That's our old cap flashing. This is 6.5. This is actually going to get us somewhere, technically, somewhere over here. A little bit lower. Now, why am I correcting? Because we're going deep in the weeds. We are going to go deep in the weeds. Okay. So that's would be the polyiso choice. And as you see here, if the membrane is here, we have no base flashing. So we just said we need 8 inches of base flashing. So we have to go up 3 bricks. Here's a rule of thumb. 3 bricks equals 8 inches. It's a rule of thumb. So that would put us up here. Minimum. Now, the question becomes, I only have 3 courses left. To do an in-wall cap flashing, and we're putting it here, I'm ghosting it in because we're not done yet. Now these bricks here have to come out. How many courses of bricks do we need to take out for the in-wall cap flashing? I already gave you the answer, but
3.
3? 1, 2, 3. Now we have nothing left. There's nothing left. We got the coping up top. That's it. So what's the point? What's the point? This is where we're going to go deep. So the question now becomes, if we have our, we like drawing dash dot. This is our base flashing. PMMA, everybody knows PMMA, polymethyl methacrylate. It's the, it's not even new anymore. It's like 20 years old already in New York. Anyway, so if this is our system, and we have to take these out to get this new cap flashing in, why are we wasting time and money putting in this copper or stainless steel cap flashing and changing out 3 courses of brick? And, if we were really going to do this right, we would have over here, your weep tubes and all that other stuff. I don't see the point. So what I would prefer to do in this scenario, you know what? Let's leave it up. Let's leave it up because we're going to go to choice B. All right. This is choice 1, which I don't like. We're actually going to modify this. Choice 2 is the vacuum insulated panel. This is a 2-inch panel. You have a 1/2-inch cover board. We're going to put a vapor barrier on the concrete deck. We're going to turn that vapor barrier up. Makes a tiny little bathtub. Actually, I would bring it all the way up. Boom, 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 to here. Then, oh, wait a minute. Oh, here's our 2-ply. oh, wait a minute, the cap flashing is in the way. So we still have to take the cap flashing out in this scenario. All right, we're going to just say, so if this is 2 inches, 1/2 inch cover board, right, and then you got couple of plies, we're going to call this 3 inches for conversation. And let's just say 3 inches gets you to the top of the second brick, even though it's probably about halfway. Now I want to do my 8 inches above top of membrane, which brings me here. Which brings my in-wall cap flashing here. It's a 2-piece, but I draw it as a 1-piece. We're going deep in the weeds, like we said. Right, here's my little receiver. Okay, and this is our cap. Now, we have to take these out. I say 2 instead of 3. For conversation, we're gonna go 2. So in this scenario, these 2 bricks are new. This remains. We're going to keep it. So this is going to be option 1. Option 2, I don't like this. I don't see why we're spending money to get that close to the coping. And in this scenario, we're going to do the brick. This is PG-13, the brick shit house. Anybody know what a brick shit house is? Brick shit house, overkill. Overkill. Solid, overkill. Or, it's not overkill. It's robust.
I was going to say, I have got a pretty fucking
Robust, right? We don't say overkill. We say well thought, well planned. So I don't like this. What I do like, now we're going to spend a little extra money. We're going to take the coping off. We're going to get rid of the old wood blocking because it's old and we want to do all nice and new, nice and fresh. Now, for purposes of this going deep in the weeds here, these bricks are going to remain. We're not taking them out. Okay? So we're saving a little bit of money there. We're going to put in a new pressure-treated block. Now, we like to put a peel and stick here. We're going to plug Grace Ultra. It's a high temperature peel and stick waterproofing. Why do we need high temperature? Because under a metal coping, it gets hot. It gets hot. We'll put in a cleat. We're going to call the pro in a few minutes, the guy that taught me a lot of this stuff. Put a cleat on the outside that nails into the wood blocking. Are we going to go really deep? Let's go really deep. How often are we putting those screws in? Some people think 6 inches on center. I was taught 3 inches on center, staggered. What does that mean? What does staggered mean? We're going to look at this in plan. If you have a plan view of the cleat, this is the out, this is the in. Staggered means, well, where are we putting the screws? Staggered means this. Just gives it more strength. Okay, so we're going to put our cleat in. Then we're going to, this is where the magic happens. We're going to take the PMMA. You know what? Do we need like a sheet on the wall probably to all that mastic and nastiness? What do we do?
Well, it's either remove the mastic or you can go back with...
Remove the mastic or...
Go back with some sort of cover board on there.
Okay. Now let's just pretend for conversation it's asbestos.
Can you just stuck over it?
I don't know that I would. Well, what we want to do is we want to bring the roofing up and over. So the question is, are we putting the PMMA, like I know it'll go on the brick, but does it want to go on the mastic? I don't know if we want to pay to take all the mastic off. I think maybe we're putting a base sheet, maybe a torch down sheet, and encapsulating it, okay? So let's say we do that for conversation. That would be down here. So let's say it's the base flashing sheet. We're going to go up. Then your PMMA is going to go this way. Up, up, up. And for conversation, we're going up and over. Maybe I didn't want that cleat on there yet. We didn't want that cleat yet. Okay, I'm going to bring that up and over, and we're going to stop it like right there. Then we'll do our cleat. Let me get this out of the way. And then we're going to go coping. All right. Are we screwing the back or are we hooking the back? I don't know. It's up to us later. So the question, from a detailing point of view, the PMMA waterproofing going up and over the whole thing, it's like an old clawfoot tub. Remember the old clawfoot tubs? Kind of went like this, right? It had like a lip, had a lip on the top. If you just have this, not as good, right? So we give it a little lip, boom, 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 a little more protection. So that would bring the waterproofing up and over. So this is really one choice. Let's go back over here. This is the second choice. Second choice with the vacuum insulated panel, we have the vapor barrier down below. We have our 2-inch panel. We have our 1/2-inch cover board. We have our 2-ply. We have our PMMA flashing. But we did have to raise this up. And in this detail, we're not replacing the coping. And what we're going to do is we're going to add up all the costs. We're going to make a phone call in a second. Could you get the chief on the phone? All right. Who has questions? Anybody have questions so far?
I do.
Please.
Would we just bring up I would assume we'd bring up the Parapro and tuck it underneath the grace sheet. Or would
We
you
could.
Would you go up and all over the whole thing?
We could. We could do both.
Okay.
So what's more cost effective? What's better? What's better for the roofing warranty? Right? When we do other buildings and you have a very simple parapet wall, when we bring our roofing up and over, we always want to try to tie it on to the air and vapor barrier on the outside so that we get our overlap there and everything's all sealed nicey. This is brick, so it doesn't matter.
Super simple question about
Yeah.
PMMA. Is PMMA always liquid applied?
Yes, PMMA is always liquid applied, yes. It's polymethyl methacrylate. It's a 2-part call it epoxy. It's an acrylic that you mix and you add a catalyst and it turns into a hard but pliable. Cures quickly. Yep. So the question is, right, if we go up and over here, we don't need to tie it on to the brick, but the question is do we bring it all the way across or do we stop it here? Well, we're going to get our roofing contractor on the phone and get his opinion on that as well. Can we pull up our detail, our parapet detail that we want to talk about? So Nick, what we're going deep in the weeds here, and the question is, let's look at the photograph, please. Photograph. Yeah, the photo that you had, that one right there. Yep. Okay.
Nick, you seen this?
I can see it.
Okay. So the question is, you have a low parapet wall. There's no insulation on this building at the moment. The cap flashing is roughly, and James can use the mouse and point, there you go. The cap flashing is roughly 8 inches above the deck. We have no insulation. We want to go back with R33. And if you notice, to get our 8-inch face flashing, okay, if we go back with poly ISO, it's going to be 6.5 inches plus a 1/2-inch cover board. We're at 7 plus the roofing, call it 7.5. So let's just call it 8 for conversation. So if we have 8 right now with no insulation, we have to add 8. That means that the cap flashing is going to go up 3 courses, and we only have 6. So it's gonna, well, is it worth it? Is it worth taking out the 2 courses of brick masonry to go back with the ISO? And then you only have like 2 courses remaining. In my opinion, we should go take the metal coping off that's 20 years old, go up and over the parapet wall with new blocking, new waterproofing, new metal coping. Or choice 2 is we go with the vacuum insulated panel, which if you go with the 2-inch panel and a 1/2-inch cover board and your roofing, we're talking 3.5 inches. We still will need to add, we will still need to remove the cap flashing because we will not have 8 inches of base flashing height. So we would like to ask you for some rough numbers to try to understand, you know, what does this all cost? Because at the end of the day, what does it boil down to? It boils down to money.
Sure.
Right? It's always, we want to do the best detail for the job, but sometimes, you know, sometimes it's just not in the budget. So could we start with a rough order of magnitude? We're not going to go with any specific companies, but let's say we're using a 2-ply modified bitumen conventional roof exposed. If we go with a base ply, a vapor barrier, and then 6.5 inches of ISO, 1/2-inch cover board, and a 2-ply, what are we talking roughly in terms of square foot? You know, let's not put asbestos into the conversation. Let's just say, pretend this was a brand new canvas. It was all cleaned out, and we're just talking dollars on the
not including the rip, right? You might
not including the rep.
This might
Not
need to get,
including the rep.
you know, tested.
What's the rip? Well, for those of us out in TV land, the rip is the removal.
Right. Yeah. You obviously want to do you know, some test cuts to see what you're working with. Once that was determined, you know, what you're looking at $7 to $10 probably removals, not ACM, right? So
Right.
like you said,
yeah,
no
not
asbestos.
asbestos.
You know, with carding fees and everything else. So there's, you know, there's definitely an expense in that. If you thought the roof was good enough and you did a moisture scan and you could get a recovery warranty on what's existing and it was fully adhered, well, I would say 35, 40 bucks.
Okay.
You know.
Now, if we added a vacuum panel instead of ISO, how would that change the price?
Excuse me. The VIP panel is it's an expensive product in and of itself. It's foil wrap, vacuum sealed. The installed cost of that is close to $30 by itself, $25 to $30, depending on the layout. You would get it from the manufacturer. They send it off to get a drawing made. You need to have, there's some infill pieces that they use out of XPS, right? Because you can't cut a vacuum insulated panel. It loses its R value at that point. So that depending on the layout, you're in that range of probably $30 additional.
Can you start writing some prices
Additional.
on the board? Like red or something like that? All right, so we have a little, behind me, we have a little dry erase board, and we're actually gonna, we'll come back to that in a minute, and we're gonna start adding some prices in.
Yeah.
Okay, so to do a in-wall flasher, let's assume stainless steel. By the way, is stainless or copper, which is more expensive, roughly? Like if you had,
Copper
is it
is-
comparable, or is it like, or is it one is definitely more than the other?
Right now, copper is more money than stainless. Right.
Okay.
Copper historically was used for its. It solders very well. It was it's very flexible, right? Soft copper can be manipulated. You could lift this cap flashing up and set it back down. Traditionally, copper was used. Stainless steel, slightly less money. You'd go with a 26 gauge. Again, if you're going to replace brick, or are we just talking about a surface
Yeah,
mounted?
let's assume we're taking 2 courses of brick out. Okay, and we're going back with a 2-piece in wall. So let's just say stainless. And by the way, is there any reason why we don't like aluminum? I mean, I have my reason. Do you have a reason why?
Aluminum is not traditionally used. One, it doesn't. It reacts with the cement, right? So you do get corrosion with the mortar quicker.
And you can't really solder it, right? Or it's
and you cannot solder.
Right.
So that's the other thing. Stainless and copper.
Right.
I mean, there's other, zinc, or there's other metals you could, lead coated copper. There's a number of materials you could solder, turn, but but the biggest reason not to use aluminum, I think, would be, yes, you can't solder it, and also it doesn't do well in those conditions where there's masonry cement condition like that.
Right. Okay. All right, so let's say we're gonna go with stainless steel. Okay, and let's say we're taking out 2 courses of brick, and we're doing a 26 gauge in wall 2-piece counter flashing. Is that $50 a foot?
No. Well, with the masonry removals?
Yeah, with the masonry
Yeah.
removals.
Oh, yeah, then yes, for
and
sure.
The new.
At least $50 a foot.
At least 50. Okay.
Yeah.
So at least $50 a foot. Okay. And let's talk metal coping. So let's go back to the detail. James, can you pull up the actual detail and just like zoom in on it? Yeah. And then zoom in right there. So this is the detail that we're looking at. This is drawn with ISO. Okay. But let's look at the coping, and let's assume new wood blocking, new pressure treated wood blocking, new Grace Ultra up over the top. And we like to do an 050 painted aluminum with a continuous cleat on the outside. Do you price that all up as like one price?
Yeah, it's one assembly.
One assembly.
Depending on the wall constructions and the width, sometimes solid wood blocking isn't feasible, and you would go with some 2 layers of plywood, right? Pressure treated plywood, and you can have clips or a continuous hook strip in the front, like you said. So there's it's a spring clip. That's a standard, like kind of off the shelf detail, what you're showing.
Right.
So there's the number of manufacturers that will sell coping as, the edge conditions as part of their package, depending if that's required for warranties. We usually shop fabricate ours.
Right.
It lends itself to not having. Sometimes you don't have all the wall widths, or you're waiting for the EFIS guy. So you can't. Sometimes it's hard to get that material quickly from vendors when you need it. So it's a job specific thing. But even a
Right.
shop fabricated coping has the same design, right? It might not have the ANSI spry sort of rating.
So let's assume, that it's just a shop fabricated 050, all right, continuous pleat on the outside, 6-inch splice plates at every intersection, with 2 lines of butyl on either side, like we like to do.
Mhm.
So with the wood blocking and the waterproofing below, what are we talking a linear foot? Are we talking foot 30, 40, 50 a foot?
I don't charge that. Yeah, you might get guys that will do it for $40 a foot, and you can the coping, especially a coping this doesn't seem like a very wide coping, so depending on your stretch out, you're definitely getting two pieces out of a sheet.
Right.
If the
I love
wall,
it. You're going deep in the weeds. What you didn't, what you're telling people is, like, you have to manufacture this. Like, you get the raw metal, right?
yeah, we it's again, if it's a standard color, which we always prefer. Again,
Bronze. Everybody likes bronze.
yeah, so post painted or pre painted, you have a
Right.
pre painted sheet. It's obviously accessible. Your manufacturer has it. My supply house in Brooklyn, uh, and you can fabricate it pretty easily and quickly, as opposed to post painting material. Then is another level of bringing it to the painter, getting it shipped back, and post painting adds $8 to $10 a square foot. But that's so. Just let's say what we're looking at here is a standard coping. Maybe it's
Yeah.
a 12-inch wall.
Call
So
it a
yeah,
12-inch wall.
yeah, I would say $50 a foot.
Okay.
Again, depending on miters and all that stuff, but I always charge, coping. I don't see copings this simple usually. The copings we deal with, and again, for new construction, this is obviously
Yeah.
this is renovation work.
Right.
Are
Right.
definitely much wider for energy code, right? There's always, you have a 4-inch cavity, you probably have an 8 to 10 inch CMU or concrete wall. So now all of a sudden, you have a very wide coping, and and uplift factors and and we're always getting calculations as well. So all of those things increase that price. If you're not, if you don't need calculations and you can use a standard color,
Yeah.
right, and the walls narrow, yeah, then I think 50, 40, $50, is probably a ballpark number.
Okay. All right. So we'll just use 50 as a higher end number.
Yeah.
All right. So for conversation, we got like $50 on the coping. What did we say on the in wall?
50.
Another 50?
Yeah, sure.
Okay.
And
So-
back.
Okay, and 30 for the vacuum seal? Yeah. And when you look at ISO, 6.5 inches of ISO versus a 2-inch vacuum panel, do you have like numbers? Do you have like square foot numbers that you work with? Or do you just say, oh, it's 20% more, 30% more, like vacuum versus ISO?
Oh, no, no, well, so say ISO, a standard ISO
Yeah.
layout without the cover
Yeah.
board, to get an R35,
Yeah.
you're probably at $4 a square foot.
Okay.
Then it depends on how many layers of adhesive you need.
Right.
The adhesive isn't cheap, right?
Right.
The low rise urethane adhesives. A vacuum insulated panel, again, probably my costs are like $22 to $24.
Okay.
So that's a huge increase
All right.
to do
So
a vacuum insulated panel.
right. So to go to the vacuum panel, now, again, the reason why you would use the vacuum panel is if you're trying to save on the height.
Height.
And you're trying, right?
100%. It's
Right.
only for it only has that purpose, because otherwise it's I think just too expensive.
Okay.
It's a great product, but it
Right.
needs, you got to handle it with kid gloves.
Right,
Right,
because
you're
if it gets
definitely
cut,
you're putting some ISO over it anyway
yeah,
to protect it, and a cover board, right? It needs to be done, and you can't cut it, right? So there's a number of issues that have that, but again, it has that insane R value per inch, whatever it is, 30, 27 per inch or something.
right.
I don't really remember. We've done a few vacuum insulated panel jobs, but again, my business is new construction, so we don't really run into it that often.
Okay. I have another question now for you. So in one scenario, okay, and we have the two scenarios behind me. It's hard to see, but
Yeah.
we could pull it back up on the screen. So in one scenario, we want to use the vacuum panel. In one scenario, we want to use ISO. And we're just trying to like determine which is more expensive. Now you see all that mastic on the you
Sure.
see all that mastic on the parapet? So
And
probably at some
conduit.
point-
And there's a lot
Yeah.
of conduit.
yeah, and you got conduits. Disregard the conduits.
I was gonna say,
But for this conversation, we're gonna disregard those.
Yeah.
But so if we're gonna put PMMA, we're gonna call it PMMA, up and over the parapet wall, take the coping off, go up and over, all that mastic is gonna cause a problem.
Yeah, you can't go over that.
Can't go over that. So do we have to abate, or do we have, when I say abate, like get all the mastic off the wall? Or are we putting like, a torch down sheet over it and then putting the PMMA over the torch down? Like, what do you think is more cost effective, to try to scrape all that crap off the wall or encapsulate it?
I think encapsulating is the best way, because even if you scrape it off, you might find mortar that's missing and stuff like that. You want a good surface. The easiest thing to do, if the wall's pretty straight, would be to maybe put a cement board or
Okay.
a Dens deck, and then at that point, if it was PMMA, then you would use a ProBase SA or ProBase PG.
No, we're not supposed to get specific with
Yeah, all right,
products.
edit that out. All right, so like you would use a
Like a
again,
torch
so-
down sheet or
so you would do a torch down sheet and then cover that, or you can direct it here, the PMMA, to the cement board. You have to detail the seams.
right.
If you didn't want to use any SBS on the wall.
Okay. So is it hands down, is it more cost effective to, like we just said, encapsulate or laminate over versus trying to scrape all that mastic off the wall? It's going to damage the bricks. It's going to be a pain.
And you have to grind, right? You also have to grind.
You gotta grind
in addition to scraping the wall, you'd have to grind the wall, prep it, apply the primer, and then you would install the PMMA. So
Now, we also don't know if that's quote unquote asbestos. We don't know.
we don't know, right? So if you're not,
And-
again, this is all if you're not getting it tested. And
Well,
if
no, assume you're getting it tested, but we're just having a conversation.
right. If you
So-
get it tested and it's not hot, then
Right.
you would maybe you do a test and see what surface
would-
you're going to come up with, and then you'd probably have to make that decision. But
Yes.
I would say without looking, without standing in front of it, looking at it and the ins and the outs, putting a sheet of cement board or a gypsum board would probably make the most sense.
Yeah.
Again, it's also if you're redoing the cap flashing, you'd maybe leave that a little proud so you could drop the cement board on top of it so you can have a nice clean finish.
Mhm.
I guess there's a number of issues, specific details I think that this particular picture would require. At that point you'd have to take off the coping, right? So
Yes.
this coping needs to come off. That leg, the front and rear legs are pretty big. I wonder if there was other problems with the top of the wall that they wanted to bring the that looks like it could be a 6-inch rear leg on that coping.
Are you talking about the splice plate? I think
No,
they
the
did this-
the coping itself. It's
down.
where
Oh, It's very tall. It's very
Yeah,
tall.
it's a big, yeah, it's a big,
No.
that looks like a big thing. So, they were, and this is obviously an older building, so we don't know.
There could be a coping stone under there. I don't
Yeah,
know.
right, exactly. You don't, and that's the beauty of, you never know what you're gonna kind of find
You
when
never
you get
know.
to these.
It's always
these-
exciting.
Right,
So I think what's interesting about what I find interesting about this conversation is you have a 2-foot wall, and look at all the thought that you really need to put into it.
yeah, and I haven't looked at this.
Everybody
This is the
thinks-
first time you're showing it to me. And as
Yeah.
the more we're talking, the more I'm like, well, then, they kind of all are interconnected, all of these, exactly like you said.
Yeah.
We don't know what we're gonna find. There's a lot of,
No, we don't know. We don't. That's the exciting part about New York City construction. You never know what the hell you're going to find,
true.
and you always find some surprise. Whatever that surprise is, there's always something. So, well, I think what we're going to do is, I think we're going to crunch a couple of numbers over here, and we're going to continue our conversation. Does anybody have any questions for Nick?
Maybe I missed it. Nick, do you have the linear footage price for putting that cement board on and then flashing up with the PMMA?
Yeah, we didn't get a cement board PMMA price. Vertical square foot.
Yeah.
So again, you'd have to, if it's a 2-foot, I almost would rather figure that in square footage, but
Yeah, that's
Uh,
fine.
Probably 25 to $30. Whereas if you didn't have the cement board, that's maybe only $1.50, $2 a material and not adhering it, but then there's more prep. So I would prefer to have the cement board because you have a nice finish, right? The PMMA on that old wall will telegraph through. So you're gonna look like you wrapped an old brick. Some bricks stick out a little bit more, right? So it's going to have that, as opposed to a nice, clean, new surface. You're not worried about it. You're pinning it in, and you're going to coat it. I think that's probably, say, $20-$25 a square foot, something like that. I mean, these are such rough, generic numbers too. I mean,
So now also, like, in theory, okay, do you like to bring the PMMA up and over the parapet wall, or do you think, hey, we'll stop it short and just do new bricks, new in-wall cap flashing? Like, what's more work? So if you think about this for a moment, you zoom back, and we have, on one hand, we're putting a cement board and PMMA, and on the other hand, you're raising the cap flashing. You got to take 2 bricks out, new stainless steel, and you leave the bricks above.
I mean, this wall is so
Money aside.
Yeah,
money
this wall is
aside,
so
like-
small. And given the way so you could, if you're really going to step back and you're not worried about your parapet height, because you're not going to have your 42 inches.
We're not talking railings. No railings.
Right.
in
So
the conversation.
we're not worried about that, and we had enough wall height.
Mhm.
I would skip the vacuum insulated panel, cut out the cap flashing. That number, right? That's the more cost effective number here, right? So, and then cement board. So you eliminate putting new through wall in. You take off
Yeah.
the coping. You take off the coping,
Right.
yeah, like you said, that probably could be an old stone coping underneath there.
Maybe.
Depending what that looks like. Maybe you wrap that whole thing. You have new Densec. You could put new Densec on the top of that too. So you could have a whole new surface from the front edge all the way down. And then you could just put an edging on, like a gravel stop. You'd
Right.
almost, right? You don't even need a full coping at that point. So the gravel stop's half the price.
Mm-hmm.
So if you really wanted to VE this thing down, that I would tell the owner, I'd be like, look, here, this is really, and you're going to get your edge to edge warranty, right? So you are going to have PMMA, and you're encapsulating that wall that is suspect. To get back to your original question, it would have to, it depends on the condition of that wall, whether you want to even address what's happening above it. If the wall's in bad shape and you know water's going to get behind, even with the new cap flashing, that's a field decision when you're going to go, look, we took the coping off. You can see how bad the wall is. There's huge cracks.
Right.
You just don't want to do all this work and have water still get behind the cap flashing and undermine. And now the owner's going to go, I just spent $500,000 on this roof and I still have leaks at the wall. And you're going to go, well, it could be coming from the wall, right? Whereas we take that out of the equation and you go edge to edge. Because again, it's such a small wall. How much water is really getting above that, especially if you're moving it up to courses? At that point, where's the through wall? What's it protecting?
Right. And
above, there's not much left to a wall
there's
that's
not much
exposed.
left. And that's why we were saying it might make sense to just get rid of the cap flashing and just go up and over. And it's a better detail.
Much better detail.
Much better detail.
So you'd rip the roof, you'd get rid of the cap flashing, and before you started, you'd probably put your cement board on the wall, then bring your roofing up to it.
Yeah.
And go all the way to the outside edge.
Okay.
Then you just have to worry about what the outside face of the wall looks like. And if that's in good shape, you know you have a 25, 30 year roof system that you've probably eliminated, half the problems that they were getting just by touching, just probably because it was coming from that wall with those open joints. So I'd probably go, as if we really step back, that's probably how this would go from a price point, right? Because that's all they really, this isn't an occupied terrace. No one really cares.
No, it's a mechanical roof. Okay.
It's a mechanical roof. So
it's a mechanical roof. And look, at the end of the day, nobody wants a roof leak, but we want to try to get the best cost-effective design that they can afford. Okay. And look, a proper roof, we all know, is going to last 20 years. So, is it worth saving a couple of bucks over 20 years? I personally rather have the most comprehensive, robust design that we can go with that's within the budget.
Right. Again, if you had a taller wall, and it would make sense. Moving the cap flashing up,
right,
that's a big endeavor, right? If you can't work within that, so you did vacuum insulated panels, left the cap flashing where it is, maybe that's a whole different route. So you'd have 3 or 4 options here.
So, all right. I think we're pretty good over here. We're going to continue on the dry erase board. We're gonna keep going. Nick, this was very helpful.
Good. I'm glad to help.
All right. Very good. We'll talk soon.
Okay.
Thank
Thanks,
you.
guys.
Thank you. Bye.
Bye.
Come on, let's figure this out. Let's go. I'm not doing this. Let's go. Do it together.
There's a calculator.
So what do we got? So I'll write, you shout it out. So let's do VIP first. We got,
For the VIP, for the system itself,
let's just call it VIP,
yep, it's going to be
Is-
$30 for the roofing assembly.
30.
Yep. There's a $30 upcharge for, no, I was saying the VIP for the roofing
All right.
system itself.
All right.
For the membranes, they're going to be 30.
And come back. Start over. So we got assembly.
Yeah.
Let's just say roof,
Yeah, so your 2-ply,
2-ply,
modified bitumen,
right?
it's going to be $30 a square foot.
I think that's low. Fine.
Alright,
We'll
let's-
put,
let's- let's
well,
put
you know
40
what?
for both.
But let's just do it. We'll do what he said.
Yeah.
30. Then,
For the vacuum insulated panel,
Yeah.
it's an additional 30
yeah,
per square foot.
okay, yep.
And then for this particular system, we would need to raise the cap flashing
So I'm gonna
with the
say,
brick, and that whole system is gonna be an additional $50.
I'm gonna say stainless steel cap,
Yep.
50 a foot.
And that's
Okay,
really where this detail stops, because we're not
Right.
gonna be touching
Right.
the coping, we're
Right.
not gonna be touching the bricks above,
right,
we're not gonna need to disturb any of the mastic that's up there. So in total, this is
Just
gonna
move
come
the
out
cap.
to.
Just move the
110.
flashing.
So 60, 110.
Yep.
Did you include the price of moving the cap, the flat counter flashing?
Yes,
Yes.
right here, 50 a foot.
Yes.
Okay? So far, so good?
Yep.
Okay. When we come over here, I'm just kind of. All right, so what do we got over here? We got switcheroo.
Yep. So this one's gonna be the same thing. The roofing assembly, the 2-ply is gonna be $30 a square foot
All right, so
again.
hold on.
That'll be apples to apples.
Roof ply, 30.
For the polyiso, we'll call it $5.
ISO, 5.
For the new coping system with the waterproofing, the blocking, $50 a square foot.
Okay.
And then in this particular case, we're gonna be doing the cement board,
Yeah.
and the flashing coming up and over. That's gonna be $25
yeah.
a square foot.
So we're gonna call it, I'm just gonna say PMMA, all right?
Which includes the cement board.
Yes, which includes the cement board. We're gonna put 25.
Now, do we wanna talk about, because this wall above is about 2 feet. So do we wanna jump this
Ooh.
number up to 50?
Ooh.
Because he did it in square footage, not.
You know what? I think that's good. I like that.
Wait, what do you mean?
So this wall is a 2-foot wall. So instead of, again, he gave us the square foot price. So this isn't, if it was a linear foot price, it would be, being that it's 2 feet tall, it should be $50 a linear foot.
Mm-hmm. Okay.
So yeah, James is saying if this is like our cap flashing here, because it's a 2-foot wall,
Double it.
yeah, we're
We're just
going,
gonna double it.
we're
If
going,
it was a
we're
3-foot wall,
doubling.
it'd be 75.
Okay, now this is even more expensive.
Yeah.
Well, hold on. Let's not get ahead. All right, so let's say let's go with the $20, but times 2, we're gonna make it
Make
40.
it 40, yeah.
Okay? Okay. Are we missing anything? No.
No.
Okay. So we got 90, 120, 125.
25. But,
The only thing you might be like, we don't know what's what's underneath the coping right now, right?
No, we don't.
So if there is a coping stone, would you remove it?
Personally, I would.
So there
That would
be
add-
a cost.
So let's say,
It's just a question mark though. We don't
but it's
know.
only the removal. we're
so
not going backwards.
maybe, so I'm gonna say stone, maybe, question mark, and let's say it's $5 or $10 a foot to throw those in the garbage.
Yeah. Just call it 10.
Let's call it 10. But that's a maybe. So we got 125, 110.
And then we're calling this a 5,000 square foot roof, right?
Right, so who's got a calculator, please? So at 5,000 feet,
It's actually. Are we doing the actual or the?
oh, you know what?
Because it's like 4,000.
We are deep in the weeds, so we are doing actual. However, but it's really the perimeter.
Yeah,
It's
that's
the perimeter. So let's just say for conversation, it's,
linear feet.
yeah, let's say it's like 60 by 60 or 70 by 70. Like, how big is that? Call it 70 by 70.
Well,
You're saying 500 square feet overall?
No, 5,000. So,
5,000.
but look, it's a perimeter.
We're talking about the perimeter right now.
It's a parapet detail.
yeah, but if we're doing that, getting deep in the weeds, this number and this number should be broken out separately from this and
That's
this.
true because we're talking
Because
about.
the square footage of the roof is going to be.
We're going deep.
So you're getting savings on the roof, and you're losing on the parapet. But the parapet's a much smaller number.
That's very
All right, well let's figure
It could
that.
actually
Well,
come out to be cheaper.
let's figure this out.
Yeah.
So let's just say for conversation.
Let's do the roof first at
Okay.
4,000 square feet.
Okay, I'm going to draw it a little more square. All right, we're going to just say.
4,000.
It's about 39, but let's
4,000.
do 4,000.
4,000. So 4,000.
Well, hold on, Violet. Can you look on the roof plan? And let's get some
Pull
real
that computer
numbers.
up on the.
Is it on the browser?
Yeah, it's in the browser. Yep.
Yeah, go to
And
the
then
roof
the-
plan.
Right here, yep.
Yep. There you go.
Zoom out a little bit.
If you zoom out.
There you go, right there.
Alright, yeah, it should be in the bottom left corner.
Yep, you had it. Yep.
Over here.
Okay.
Go down a little bit?
Well, that's it though. So,
No, but you want the area of the
Yeah, we
roof.
want to know the area.
Go down,
Roof area, yeah.
go down.
a little more.
Go down. Right there.
Oh,
No, you have it.
all right, so
39.4.
39.
4,000. 4,000.
Times 35 for the ISO.
All right, so hold on one second. So 4,000, somebody,
I'm
calculator?
doing that.
All right. 4,000 times
35.
35,
Yep, and that's for the roof assembly and the ISO.
140.
$140,000?
Yeah.
140. I'm just going to put 140.
And then we need, what did we say the linear footage was?
It would be 65, if it's a square, 65.
Well, it's not. It's.
Oh.
it's
No, so we're gonna have to kind of add these numbers up. 14.
can we
25.
polyline that, or is that too much?
This is,
I got
in,
it. Just 14.5 plus.
so 14 plus
All
25
right, go ahead.
Okay.
plus 8, 23, 13, 29, 47, 11, call it 14 again, and then can we just scroll down ever so slightly? 87.
271.
So 271 times, and it needs to go up 90.
Wait, what was the perimeter?
271.
That's it?
271.
That sounds low.
No.
All right, fine. 270. So 270 linear feet.
Times, are we including the stone or we're just doing this right now?
No, that's we don't know. We don't know that. We don't know if the
Times
stone
90
is
for
there.
that.
Times 90?
Yep.
24,000.
24,000.
Times 90.
Times 90.
270
Times 90.
times 9. 24.3.
Times 90.
Yeah.
24.
0.3.
That's way too low.
270 times 90?
Yeah. 24,300.
Yeah.
All right, fine. So
So the total would be
yeah, so we're talking 164.
130. Yeah.
All right, let's go over here. So the same. So we got 4,000
Times 60 this time.
times 60 is 240. Correct?
Yeah, and then it's gonna be 270 times 50.
That I don't know. 135?
13.5.
Yeah. 135? Or 13.5?
13.5.
Okay. So we're talking 253.5.
So you're almost looking at $100,000 in savings for a better repair.
Whoa, hold on. The deep in the weeds moment.
Yeah.
100 and what? How much?
Almost
100.
100,000.
Almost $100,000
Yeah.
to do, in my opinion, the better detail because we're going up and over.
Yeah.
Yeah.
And we got a new coping, new base flashing. What I don't like over here is this is all old. Could something go wrong? I don't know, but you know what this is? We know what this is. Change order.
Yeah. And it's also unknown.
Because what's going to happen, they're going to say, oh, we got all this brand new roof and this and that. Oh, why didn't we do that? And then they'll do it later. And then it's like, oh, we should have done it to start with.
You're also missing the gap between the counter flashing
Yes.
and like that could be leaks there.
Yes, right here. This is the deep in the weeds moment. This is your weak spot, right here. That little bit that you're saving. Look, it's only a couple inches. It's like 4 or 5 inches to save. But you save that money, and if you get a leak, you're in trouble. So believe it or not, the more robust detail is more cost effective.
Yeah. And then the other thing to think about is on both of these, like Nick had mentioned, the only issue with there is your outer wall. That would
Yes.
only been, but your $100,000 in savings,
Maybe you cut and point the wall.
you could repoint this. And then it's, they're just,
And-
that's
and-
$10 a square foot.
right? And now you have a nice, fresh, clean wall, right? And now look at all that blue. Blue is waterproof, up and over.
Yep.
Okay. The verdict is in.
Polyiso is the winner.
Polyiso.
By knockout.
All right. Do we drop the mic? Drop the coffee? That's it.